This is Trek Zone's Talkin' Science.
Welcome to Talkin' Science, your bite-sized wrap of the latest science and space headlines. Coming up today, from red giant supernovas to remote WA radio telescopes painting a map of the night sky, attempting to answer the question of why the sky is blue, and Gilmour Space partner with Macquarie University. Lots of details, let's get into it. Bizarre quantum properties of black holes, including their mind-bending ability to have different masses simultaneously. It's a lot of words, I'm getting there. Have been confirmed by University of Queensland physicists. The team developed a mathematical framework allowing us to place a particle outside a theoretical mass superposed black hole. Mass was looked at specifically as it is a defining feature of a black hole, and as it is plausible that quantum black holes would naturally have mass superposition. Our work shows that the very early theories of Jacob Bekenstein, an American and Israeli theoretical physicist who made fundamental contributions to the foundation of black hole thermodynamics, were on the money. Research co-supervisor Dr. Magdalena Zeik said. An international team of scientists, including researchers at the University of Adelaide, have gathered new evidence about the energetic core of an active galaxy millions of light years away by detecting neutrino particles emitted by it. The scientists have found that NGC 1068, also known as MEISA 77, in the constellation of Cetus is a high-energy neutrino emitter, and they've observed the particles using the IceCube Neutrino Observatory in Antarctica. Now, neutrinos are subatomic particles that normally pass by the trillion through our bodies and every part of the Earth every second, but they rarely interact with matter, which makes them very difficult to detect. Put together some clever scientists, a common form of yeast, and a 3D printer, and you'll get a versatile and nutritious food system for the next generation space traveller. In a new Nature Communications paper, researchers from Macquarie University and the ARC Centre of Excellence in Synthetic Biology outline a vision for a customisable food system that provides dishes with the taste, texture and nutrients of their earthbound counterparts. The primary ingredient used in the space food system is a yeast with the fanciest name I could never hope to pronounce, so I won't even try. Nonetheless, it's a food-grade microorganism with thousands of years of usage in baking, brewing and winemaking. Yeast cells are already nutritious, containing substantial protein, carbohydrates, small amounts of fat and most essential amino acids that humans require from food. And with some engineering, it's been discovered that the yeast can be further bolstered to add nutrients, taste, colour and even texture. Well, a new paper by the Swinburne University of Technology and the University of New South Wales is helping to solve the very heart of age-old questions like, why is the sky blue? It studies whether stars that are almost identical twins of the Sun have the same strength of electromagnetism. If they didn't, it would help researchers in the search for a new theory that ties all of the nature's laws together. The team of students, postdoctoral and senior researchers at Swinburne and UNSW discovered that electromagnetism had the same strength in 17 solar twins to just 50 parts per billion, making it the most precise astronomical test of its time ever performed. Back in 2010, Hubble snapped 3 images of a red giant in the Abell 370 galaxy cluster GO supernova. And in the last few months, international researchers on a systemic research of archival images found them. Those images, peering back around 11.5 billion years, show the beginnings of a star-going supernova, something that they say has rarely been observed before. The team found that the radius of the star appeared to be about 530 times larger than our Sun, and say that there was a rapid cooling of the star which took place over 8 days. A radio telescope parked in the remote Western Australian outback is building a 3-dimensional map of the night sky, placing galaxies up to 1 billion light years away. Published a few weeks ago in the publications of the Astronomical Society of Australia, the Wallaby, the Wide Field ASCAP L-Band Legacy All-Sky Blind Survey the pilot survey from that will be sharing its first data release with the scientific community, helping us to better understand nearby galaxies and galactic clusters. Over the course of the survey, 250,000 galaxies are expected to be catalogued, helping researchers measure the dark matter distribution, internal motion of galaxies, and how these systems evolve and interact. And lastly this week, Gilmour Space have announced a partnership with Macquarie University's Australian Astronomical Optics Unit to develop satellite tech with applications more relevant to Australia, which will reduce their expenditure and reliance on foreign nations for critical infrastructure and also grow onshore industry with a strengthened capability for supply chain and tech partners. As part of this new partnership with Gilmour Space, a team of technical specialists from AAO Macquarie will construct and deliver a thermal camera payload. Looking forward to that. Loving all the work that they're doing at Gilmour Space. Well, Dr. Brad's here on the first Tuesday of every month to bring us a roundup of the biggest stories across the past month. And I've got your bite-sized wrap of the week the other 3 Tuesdays, just like this episode. Thanks for watching Talking Science. I'm Matt Miller. I'll catch you in the comments.